talk about the subatomic world. And then we'll talk about what it's telling us about reality. The first thing I want to tell you about the subatomic world is it's totally a fantasy created by mad physicists trying to figure out what the heck is going on when they do these little experiments. By little experiments, I mean big energy in little spaces and little pieces of time. It gets pretty nutty at that realm of things. And so subatomic physics was invented to try to figure that all out. We need a new science down there. It's called quantum physics, and it is subject to a whole range of debatable hypotheses, thoughts, feelings, intuitions as to what the heck is really going on.
We were all taught in school that the world is made of stuff, of matter, of mass, of atoms. Atoms make up molecules, molecules make up materials, and everything is made of that. But atoms actually are mostly empty. For example, if this ball were the nucleus of an atom, a proton in a hydrogen atom, for example, then the electron circling this, which would describe the outer limits of that atom, would be out by that mountain over there, roughly 20 miles away. And everything in between is empty. In fact, the universe is mostly empty. However, when we go down in scale in the emptiness, we eventually come to a level, the fundamental level of space-time geometry, the fine basement level of the universe, where there's information, there's a pattern. It's called the Planck scale, and it's the fabric of the universe. And at that level, there's information that's been there since the Big Bang. So most of the universe, even of matter, is actually empty. The Planck scale is the very smallest level of reality. If we go down in scale, we're at meters, centimeters. If we go down to atoms, or 10 to the minus 8th centimeters, keep going down and down and down. Space-time is smooth until we get to the basement floor, the bottom level, where there's a pattern, there's a fabric, if you will. There's some kind of coarseness or irregularity. And that's at what's called the Planck scale, after Max Planck, the German physicist, at roughly 10 to the minus 33 centimeters, and the Planck time is 10 to the minus 43 seconds. So things are very, very small and happen very, very fast. Now, despite the fact that they're very, very small, space-time is everywhere, so the entire universe is created of this level. And Einstein's relativity says when this fabric curves up, it forms mass, and that's what matter is made of. The universe is very strange. There seem to be two sets of laws that govern the universe. In our everyday classical world, meaning at roughly our size and time scales, things are described by Newton's laws of motion, set down hundreds and hundreds of years ago. And they work very well for billiard balls and cannonballs and gravity. However, when we get down to a small scale, when we get down to, say, the level of atoms, a different set of laws take over. These are the quantum laws, quantum theory, quantum mechanics. And at that level, particles may be in multiple places at the same time. They may behave as waves smeared out spatially and temporally. They may be interconnected over great distances. They may be unified into one quantum state, into one state, governed by one wave function. And the borderline, the threshold, this curtain between the quantum world and the classical world is really mysterious. It's called sometimes the collapse of the wave function, because at the quantum world, everything is in superposition of multiple possibilities, and in the classical world, these multiple possibilities seem to collapse to particular definite choices. So everything is in one particular place.
When we look at some of the modern scientific views of reality that have tried to get down to the nitty-gritty, we see that at its ultimate level, say in M theory or string theory, that reality is not solid, it's mostly empty space, and whatever solidity it has seems more to resemble a hologram picture rather than material, harsh, solid reality. It's a shimmering reality that seems to be very susceptible to the power of thought.
Quantum mechanics is really the play and display of information, the play and display of potentiality, waves of information, waves of potential electron. And it's important, the word potential. This isn't the world of electrons, it's the world of potential electrons. But when you have to ask the question, waves of what, really? What is the field that is waving? Is it the ocean? No, it's a universal ocean, an ocean of pure potentiality, an ocean of abstract potential existence. We call it the unified field, or superstring field. And that's what we're made of.
The notion that things that we touch with our hands, feel, are made of ideas or concepts actually is probably an older idea than we might have thought. And it's a difficult idea to really grasp or get a hold of. But let me try to explain it this way. When we began to look at small corners of space and little pieces of time, we began to see that the objects that we discovered in these regions of space and time weren't just persistently existing. They were kind of popping like bubbles in bubble wrap. Pop, 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 on and off, on and off. And in order to explain that, we wondered what they were doing when they weren't appearing as pops. What were they before that? Then we did more refined experiments, and we found that we could take objects and let them interact and fly apart, and then measure something about one of the objects, and we'd find that the other object would also change at the same time that the first object was even looked at. In other words, if something popped over here, instantly the other one would pop, whereas if we hadn't popped this one would just pop randomly. So how could pop 1 be connected to pop 2 when they weren't separated? So this gradually led into some notions that there was an invisible connection between everything. Physicists give this a name. They call it entanglement. Or we now speak of it in terms of a state, or an invisible state. We call it a state vector, or a quantum wave function, because it seems wavy. It seems spread out over space and time, rather than concentrically localized in one place at one time. However, this wave function isn't just a wave of matter, like an ocean wave or a sound wave or any kind of wave of matter. It's a wave of possibility. It's a kind of thought wave. And because it is a wave of thought or possibility or not matter, it's invisible to us. But we can't explain what we do see as matter in these small corners of space and time unless we picture that these matter particles somehow come out from or emerge from these thought wave patterns which are invisible to us.
When electrons move about the atomic nucleus, they do so in orbits. You have seen such models of the atom in high school books. You can easily recall them. But the subtle part comes when we think of how does the electron jump from one orbit to the other. A jump that is associated with the emission of light from atoms. Atoms emit light in the process. But how does the electron jump from one orbit to another? Niels Bohr was the first one to point this out, and it's radical. Electrons never go through the intermediate space, to the intervening space. Electrons never traverse any space in making this transition. They just are in the higher orbit, and then they are in the lower orbit. No space in between. So how does one make the jump? If you think in terms of continuity of movement, you can't find answers to that. So quantum fundamentally then means a discontinuity. This word quantum, originally it just meant a quantity. In Latin it just means quantity. But that's not the way we use it in quantum physics. From the beginning, we used the word quantum in quantum physics to signify discreteness, and now signify a quantum leap, a discontinuous movement.
Quantum mechanics guarantees that the deeper you go, the more energetic nature becomes. It's for this reason that nuclear power is 1,000,000 times more powerful than chemical power. Why? Because chemical power represents a molecular manipulation. Nuclear power emerges from a nuclear manipulation. But the nucleus is 1,000,000 times smaller, and 1,000,000 times more fundamental, and 1,000,000 times more powerful than the chemical level. So the deeper you go, the smaller you go, quantum mechanics says, the more dynamic you become. The unified field exists at the ultimate scale of the Planck scale, 10 to the minus 33 centimeters.
Most people think that the vacuum is empty. But for internal self-consistency of quantum mechanics and relativity theory, there is required to be the equivalent of 10 to the 94 grams of mass energy, each gram being E equals mc squared kind of energy. Now that's a huge number, but what does it mean practically? Practically, if I can assume that the universe is flat, and more astronomical data is showing it's pretty darn flat. If I can assume that, then if I take the volume or take the vacuum within a single hydrogen atom, that's about 10 to the minus 23 cubic centimeters. If I take that amount of vacuum and I take the latent energy in that, there is 1 trillion times more energy there than in all of the mass of all of the stars and all of the planets out to 20 billion light years. That's big. That's big. And if consciousness allows you to control even a small fraction of that, creating a Big Bang is no problem.
Organizations like NASA, British Aerospace, are all trying to tap into this incredible, unimaginably large energy sea. And they feel if they can tap this, we can travel to different galaxies. So they understand that in empty space, there is this unbelievable energy.
When you begin to really grasp this, you begin to grasp the enormity of the energy that would be involved in going down this rabbit hole. What is available for us to use in the future to take us to the stars? The issue is we are perturbing this with consciousness. We are able to, with directed consciousness and intention, we are changing things at the vacuum level, which then allow us to access a new level of physics. So we can do that at that level, not so much at the atom molecule level. That's a secondary effect. So we're already doing it in essence. We're already getting into the rabbit hole by using intention.
We're really living in a thought universe, a conceptual universe. Quantum mechanics is just the play and display of potentiality.
The major basic idea that quantum physics implies, which makes us understand this or even think about this new paradigm, the thing which is that there's this underground, there's got to be a realm of existence which cannot be ever touched on or seen, which bubbles into the existence giving rise to our understanding of the world.
The tighter physics have tried to grasp onto physical reality, to understand what it's really made of. What are the core building blocks of life? At the basis of it all, life, the universe, slips through your fingers. And you come up with something that's increasingly abstract to come to the realm of pure abstraction. And that's what the unified field is. It's pure abstract potential, pure abstract being, pure abstract self-aware consciousness, which rises in waves of vibration to give rise to the particles, the people, everything we see in the vast universe.
What makes up things are not more things, but what makes up things are ideas, concepts, information.